What's up, everyone? John Krum with OMC. I'm here with Tyler Niday, the founder and CEO of Bonsai. We want to kind of update you guys. Bonsai launched how many years ago, Tyler?
Yeah, we're about 2.5 years old now, so it's been a pretty amazing wild ride with lots of new products and machines with customers right now. It's been very exciting.
Oh, sorry about that. Yeah, no, and if you guys remember early on, we got in the field right away and we were very aggressive about showing you guys the exciting things that Bonsai is doing and showing you the autonomy based on vision that they're providing us. Tyler, why don't you kind of update the OMC team and just people in general, like what's going on out there with Bonsai?
Yeah, it's been an exciting time. We have vision-based autonomy on multiple form factors. AR500s doing multiple jobs like blast spraying. This is a 1,000-gallon aerofan sprayer to weeded applications, right? We have about 40 machines delivered to customers right now with shakers and AR500s and going through harvest right now. It's been a really exciting time, but we're able to navigate through a dusty, dynamic orchard with multiple form factors and really impact the labor potential on the farm. It's been really great.
Awesome. So for a guy that doesn't know anything about Bonsai, right? Like they're like, okay, I see the machinery, you know what I mean? I'm in ag. Tell me and let's show me real fast. What in the simplest form do you guys do and what do you guys provide?
Yeah, so we provide the full package, right? To run an autonomous tractor like this, you have to start in the app, which is over here. This is a mission plan running, right?
Yep.
So you have multiple machines, you have a plan, you have to know where you're gonna go, what's gonna happen. So this is a AR500 doing a blast spraying job on a field in Australia running. So you have global plan, you need to know what's going on with the sprayer. If an event happens, if there's a stop event, right, what happens to be able to restart the machine from your truck or your console, right, when you need to spray, right? And ultimately, this technology is really great because in this field, there's no connectivity, there's limited abilities to get RTK GPS, so you really have to navigate off vision. There's tons of adverse conditions in the orchard, like overhanging limbs where traditional perception computer vision systems can fail, and our solution really enables you to get through all those edge cases and work dynamically and quicker in a lot of applications. So it's pretty exciting.
No, that's awesome. Like we've seen the benefit. Obviously, we're working with you guys very closely.
Yeah.
What's the benefit of vision versus all the other, I would say, autonomous like standards? What would you say that your guys' edge is versus something like that?
Yeah, great question. So one thing we really had to solve for when we started was shakers and sweepers. Shakers and sweepers are super, super dusty, right? And you've probably heard of a LiDAR. It's a system that shoots a laser out and measures the time it takes for the laser to bounce an obstacle and come back. Now, if there's a dust cloud, right, that's a big issue. You don't see the obstacles. So our system's unique in that we trained about 500,000 acres of orchard data to be able to see things through dust, right? So unlike, other forms of computer vision called stereo vision, we really work like a human does, where we match features. We don't match pixels. We match features that enable us to really navigate in these adverse conditions ultimately. So it enables us to shake, it enables us to sweep, or do a blast spray application.
Yeah, that's awesome. We're going to show you guys. Let's walk over to one of the AR500s and why don't you show us some of the cameras that are on this machine?
Yeah. So you got to look closely ultimately, but here's one right here. But there's actually 6 cameras on this machine. They're overlapping and they create a 360 bird's eye view of what's going on. So the actual system really knows what's happening around it, right? So there's one camera here. This is a wide field of view fisheye camera. There's 2 cameras on the front of the machine here. There's the other camera on the opposing side, and then there's a rearward facing camera that's actually looking at the job being done. So sure, we have sensors on the sprayer to know if there's a clogged nozzle, if there's a pressure drop, right, if anything happens. But we also have this rearward facing camera that can see if a human approaches the machine or anything happens to really have safety and good job quality. For any autonomous application, you got to start in the back with the implement and then go to the front. An autonomous tractor is nothing unless you have the job being monitored and a quality job happening. So
that's awesome, man. No, like I said, we've really seen you guys grow over the last 2.5 years, and you have a huge, extensive background inside of the ag industry. Why don't you give us a quick overview of your journey? You know what I mean? Like real quick, like high level. How did you kind of get into this? And you're not just some guy that just came out of the nowhere and just decided to bring Bonsai into the group. You know what I mean? Into the ag industry. So give me a quick idea of what that looks like for people that are curious.
Yeah, completely. So I started my career after getting an ag engineering degree at OMC.
Yeah.
It was like thrown into the fire working for Don Mayo and Brian. It was amazing. I learned so much so quickly, but I got to do mechanical design and then start doing the drive-by-wire programming. And that was really the eye-opener for me.
Yep.
I then joined a company. It was the first ag-robotics computer vision startup I'd heard of, Blue River Technology. And we built see and spray applications. So you see a weed and you spray just the weed. It was really a transformative company and product. John Deere acquired the company, and after the acquisition, I got to be the first engineer and build out the John Deere autonomy stack on large-scale 8R tractors. So full computer vision stack doing 24/30 deep tillage. It was really great, and came back to the orchards because I feel like the orchard space has not gone through the same precision revolution that precision agriculture revolution that open field has, right? There's been tons of mechanized advancements. It's amazing, right? An almond orchard's mechanized end to end. It's one of the few crops, but there isn't GPS auto steer. There's no variable rate spraying. There's a lot of limitations, and I really feel that if you build a vision-based system that could work where GPS doesn't and work in the dust, you can really enable this next phase of the orchard. So pretty exciting.
No, that's awesome. Let's go over to the shaker side and just kind of show us real quick about that. All right, so we moved over to the shaker side, which is probably, I'm assuming, a little more complicated. And being a sales guy and watching it, autonomous tractor, straight and narrow, keeping it down the lane. Shaker has multiple functions, right? And a lot of other things to look out for. And I think that's what makes you guys unique and special. So why don't you tell us a little bit about this?
Yeah, the shaker's a really interesting product, right? It's the slowest job in an almond orchard, right? A traditional shaker, you stop at every tree and you have to manipulate the arm to grab each tree.
Yep.
This machine's really unique. Enabled with the Bonsai system, we actually position and skeletonize every tree so the AI and autonomous software knows where it is, but also where the tree is. So with this machine, it's a continuous motion platform. For every tree, we actually steer and adjust the reach and the pitch so that the shake's in the perfect spot every time. This machine's continuous motion, so one of the other benefits apart from labor is that it can run at 50% to 75% faster because it never stops, and with a 30% reduction in fuel. The engine output's always at peak engine output, so it's a pretty awesome machine. There's no starting and stopping, it just runs through the orchard. And our vision system is really the enabler to get there.
Yeah. No, awesome. So some growers have seen this in the field, and like I said, we know that people are making purchases right now and looking at this type of equipment. Based on where you first started 2.5 years ago to current, to what are we looking forward to in 2025 and 26? Where are we at?
Yeah, it's pretty crazy because I think 2 harvests ago, we had the first iteration of this machine. We could barely make it drive straight. There was no head control. There was no human detector, no obstacles. And now it's like watching this machine run. It's like a amazing algorithm that's like finding the perfect placement in these crazy hills and crazy berms. So very, very exciting. But I'm really excited about the future. I think we can really imagine the production system as a whole and really get to new form factors and new ways of doing things enabled by autonomy. I'm very excited about multi-use tractors, right? And using autonomy not as just a labor replacement, but doing new ways of doing things during harvest and off harvest with these machines. It's going to be exciting.
Right on. Well, you guys heard it from here. We wanted to update you, and these guys are, we're hand in hand and working with them almost every day, really, and the reality is. And we wanted to kind of keep you guys updated of what's going on and where we're going. If you haven't seen one yet, you can ask for a demo. We can get something in the field or even relate you to someone that's made a purchase and using it right now. So thanks, Tyler. Appreciate it.
John. Pleasure.
Right on,
Appreciate it.
See ya.